Work today is broken. We're all working in too many disconnected apps, and it's killing team productivity. But for the first time, there's a platform that fixes it by combining everything you need: projects, chat, and knowledge in one place. It's all powered by the world's most complete work AI, so you can find answers from anywhere and get work done faster.
Welcome to another crash course. Today we're going to be talking about how you can implement user authentication in your web applications using Node.js, Express.js, and Passport.js. Now, the way that I've set this up is in a series of videos, and we're first going to kind of jump into what are your authentication options in general. I know that's a question that I had for a long time. What do we have? I hear stuff about JWT, username and password, and then you've got all this other stuff like OAuth and even some custom strategies that you can use to authenticate your users. So we'll go through that. Then we'll talk a little bit about the Passport.js framework, what it is, what kind of structure does it use to authenticate users into the apps, and then what are some of the different strategies that you can use within it. And then finally, we'll actually go into the implementation of the Passport local strategy and the Passport JWT strategy. Although we'll talk about which strategies we might use in different situations, both of these strategies are going to be really good for anyone who is just trying to get their app off the ground, and their primary focus is not necessarily on authentication, but they actually need authentication to get it off the ground. So these are kind of like the bare bones, most basic way to authenticate users into an application, and is going to be great for individuals, small teams, startups, anyone that is building their application from scratch. There are a few prerequisites for this tutorial series. I've pretty much assumed that you already know the basics of coding within the Node.js ecosystem. So that means you have a pretty good understanding of Node.js modules and package.jsons, all of that kind of stuff, as well as things like the Express framework. Also things like asynchronous programming, so promises and callbacks. Hopefully you're at least a little bit familiar with all of the topics here on the screen. If not, you can still get through the tutorial, but I would highly suggest kind of brushing up on anything that you don't have a very basic understanding of. This being the first video of the entire series, I want to walk through what you're going to see. We've already kind of touched on it, but you can peruse the slide that's up on the screen right now for a few moments just to see what kind of topics we're going to be covering. Now, the way that I've laid this out is it's going to be in a YouTube playlist, so you'll see all of the videos in sequential order. But the videos that are considered to be the core lessons of this tutorial series will have something like a 1 out of 5 or 1 out of 10 or part 4 out of 10, whatever it may be. And then the non-core lessons, kind of what I could call filler lessons for knowledge gaps, are going to be included in the order that you probably should watch them, but you don't necessarily need to watch them if you already have a pretty good grasp on those topics. So I'll try to, during the video, mention, hey, you should probably go check out this video if you're shaky on this concept, and then you can pause the video, go watch the one that you need to, and then come back. The first thing that I want to cover is what are your authentication options here. Before we get into any coding, it's pretty important to take a look at what's available to us and deciding what is my use case and what's going to be best for that use case. So on the screen, I've laid out all of the authentication options that you might find if you are in the Node.js ecosystem or any other ecosystem for that matter. And they are listed from least complex to most complex, but that does not mean that the least complex option is the worst option. It just means that as you kind of move up that chain, it's going to require a little bit more understanding, more pieces that you have to understand to implement the strategy itself. In the scope of this tutorial series, we're just going to be sticking with the left two, so the session-based authentication, aka the Passport local strategy, and the JSON Web Token or JWT authentication, or aka the Passport JWT strategy. Now, you also have a little bit more complex authentication that you'll see, especially if you're trying to use a large API like maybe the YouTube API or any Google API, even GitHub's API. These big companies rely on OAuth. It's just a protocol to give different access rights to users trying to access resources within their API. So you'll kind of get the gist of what that is as we get into the JWT authentication, but I'm going to stay away from completely diving into the OAuth. Although we're not going to actually get into the coding implementation of solutions like OAuth or even custom solutions, it's definitely important to at least touch on it. So what OAuth is all about, it's just a protocol, and I know that can get pretty confusing when you have software as a service providers such as Auth0 and Okta, among others, that actually provide this OAuth protocol as a service. So it's really confusing if you look at those companies, namely one that's named Auth0, which sounds like a protocol. It gets really jumbled in your head, like what's the protocol, what's the company, how is all of this working? So really what the OAuth protocol aims to do is separate out the two components of we'll call user authentication. I got to be careful with the terminology here because there's a big difference between authorization and authentication. So on the left, with the JWTs and the local logins, the session-based authentication, that is all about knowing who the user is, and that is what we would call authentication. Now, on the other side of things, if you have seen things like social logins, like sign in with Google or sign in with Facebook, that's a little bit more about authorization. So that's it's not as much who we're talking about, but instead who has access to what resources. So in other words, you'll get into things like scopes, what does this particular subject or user have authorization to access? Does it have authorization to make just GET requests against the API, or does it also have authorization to edit certain resources within the API? So as you might guess, using the OAuth protocol, and you'll also hear things like OpenID Connect is closely related, that is going to be used with these bigger services where, maybe one company, such as Google, allows users that have varying authorizations to access the API in the same way. So if I or you wanted to access resources from, say, Google's YouTube data API, so if we wanted to get YouTube analytics or something like that, we don't have authorization to do certain things within that API, and that is defined by the scopes that we are basically provided in our access token that's related to the OAuth protocol. Now, I know all of that sounds very complex, and it's definitely not something that you can even begin to understand completely in just a few minutes, but I did want to talk about that and kind of just mention what it is and why we're not going to get into all the details of it. I think we have plenty on our plate with the session-based authentication and the JWT-based authentication to even start talking about that. So those are your options. We're going to stick with the two on the left, the least complex ones, and
Yay, let's
probably the
go,
most
Brown!
common implementations that you'll
Brown!
see for startups and people who are just trying to get their application off the ground and worry about the complex authentication of it a little bit later down the road when they have either more resources, more money, or both that can actually spend the time to implement something a little bit more complex like the OAuth protocol that you need.
Is your agency using WordPress to build websites? That's like carving a chicken with a handsaw.
Need to, and then come back. The first thing that I want to cover is what are your authentication options here? Before we get into any coding, it's pretty important to take a look at what's available to us and deciding what is my use case and what's going to be best for that use case. So on the screen, I've laid out all of the authentication options that you might find if you are in the Node.js ecosystem or any other ecosystem for that matter. And they are listed from least complex to most complex, but that does not mean that the least complex option is the worst option. It just means that as you kind of move up that chain, it's going to require a little bit more understanding, more pieces that you have to understand to implement the strategy itself. In the scope of this tutorial series, we're just going to be sticking with the left two, so the session-based authentication, aka the Passport local strategy, and the JSON Web Token or JWT authentication, or aka the Passport JWT strategy. Now, you also have a little bit more complex authentication that you'll see, especially if you're trying to use a large API like maybe the YouTube API or any Google API, even GitHub's API. These big companies rely on OAuth. It's just a protocol to give different access rights to users trying to access resources within their API. So you'll kind of get the gist of what that is as we get into the JWT authentication, but I'm going to stay away from completely diving into the OAuth. Although we're not going to actually get into the coding implementation of solutions like OAuth or even custom solutions, it's definitely important to at least touch on it. So what OAuth is all about, it's just a protocol, and I know that can get pretty confusing when you have software as a service providers such as Auth0 and Okta, among others, that actually provide this OAuth protocol as a service. So it's really confusing if you look at those companies, namely one that's named Auth0, which sounds like a protocol. It gets really jumbled in your head, like what's the protocol, what's the company, how is all of this working? So really what the OAuth protocol aims to do is separate out the two components of we'll call user authentication. I got to be careful with the terminology here because there's a big difference.
Puwede ba mag-aral ng pilay at sasamahan? Siya ang may nagparang matamit na sinang mag-aakalang lalaki pala ang bibiyag sa tulad ng libreng gala.
Difference between authorization and authentication. So on the left, with the JWTs and the local logins, the session-based authentication, that is all about knowing who the user is, and that is what we would call authentication. Now, on the other side of things, if you have seen things like social logins, like sign in with Google or sign in with Facebook, that's a little bit more about authorization. So that's kind of, it's not as much who we're talking about, but instead who has access to what resources. So in other words, you'll get into things like scopes, what does this particular subject or user have authorization to access? Does it have authorization to make just GET requests against the API, or does it also have authorization to edit certain resources within the API? So as you might guess, using the OAuth protocol, and you'll also hear things like OpenID Connect is closely related, that is going to be used with these bigger services where, maybe one company, such as Google, allows users that have varying authorizations to access the API in the same way. So if I or you wanted to access resources from, say, Google's YouTube data API, so if we wanted to get YouTube analytics or something like that, we don't have authorization to do certain things within that API, and that is defined by the scopes that we are basically provided in our access token that's related to the OAuth protocol. Now, I know all of that sounds very complex, and it's definitely not authorizations to access the API in the same way. So if I or you wanted to access resources from, say, Google's YouTube data API, so if we wanted to get YouTube analytics or something like that, we don't have authorization to do certain things within that API, and that is defined by the scopes that we are basically provided in our access token that's related to the OAuth protocol. Now, I know all of that sounds very complex, and it's definitely not something that you can even begin to understand completely in just a few minutes, but I did want to talk about that and kind of just mention what it is and why we're not going to get into all the details of it. I think we have plenty on our plate with the session-based authentication and the JWT-based authentication to even start talking about that. So those are your options. We're going to stick with the two on the left, the least complex ones, and probably the most common implementations that you'll see for startups and people who are just trying to get their application off the ground and worry about the complex authentication of it a little bit later down the road when they have either more resources, more money, or both that can actually spend the time to implement something a little bit more complex like the OAuth protocol. To wrap up this introductory video, I wanted to give a brief overview of what the Passport.js framework is. And the reason being is we're actually going to be implementing two different strategies within the Passport framework, but that just basically means that we have two different middlewares that are connecting into the bigger Passport.js middleware. So you might ask, what is a middleware? For those that are not familiar what middlewares are in Express or are just a little bit fuzzy on how they work, I have created a video that will be included in this playlist so that you can brush up on that and get yourself up to speed. But basically all that Passport.js is a middleware that integrates within your Express.js application and handles all of the authentication logic using the specific strategy that you choose to plug into the Passport.js framework. Now, the strategies that are included, if we go to Passport.js, we can go to the home page and see that there are plenty of different strategies here. So We can do anything from the Passport Local and Passport JWT, like we're doing. And we can also do something a lot more complex. You can see that we have stuff like the Passport OAuth 2, which is what we just talked about, or even something more specific, Passport Instagram. We can use the Instagram login to authenticate and delegate access to our users. So there's a lot of different strategies, and all of these strategies have been created by independent developers that basically say, okay, here's the Passport.js framework. It's just a middleware, and it allows me to kind of use that framework as a starting point, and then we can just build in the specific pieces of authentication in our own middleware, which we call a strategy. So in summary, Passport.js it's just a middleware, and it allows me to kind of use that framework as a starting point, and then we can just build in the specific pieces of authentication in our own middleware, which we call a strategy. So in summary, Passport.js is just a framework that is a middleware that also allows individual developers to develop other middlewares called strategies that connect in with this bigger middleware that we call the Passport.js framework. And then all of that gets wrapped up into a bundle and put into your Express app, and it works seamlessly with your Express routes. We'll see in a lot more detail how each of these strategies, the local and JWT strategy, work as we go through the series, but it is important to just understand the basics of what this is. If I had to sum up the code logic of Passport.js in a few sentences, it would basically be this. So Passport.js is a middleware, as we just talked about, and on every HTTP request that a user calls to our Express server, the Passport framework is going to first pick up, okay, what strategy are we using here? And then it will use that strategy to say, hey, is that user that just requested that resource authenticated? If that user is authenticated, then Passport is going to let that user access the resource. It's going to, go into the Express route. If that user is not authenticated based on the strategy we're using, then Passport's going to return a 401 HTTP status, which is basically the unauthorized status. So that's kind of Passport.js in a nutshell. Again, it's going to get a lot easier as we see the actual code flow of what's going on with this middleware. And with that, I think we are done with the introduction to this series. If you are wanting to implement the Passport local strategy, then it should be just the next couple videos in the series. I think I'll throw in some of those optional topics in there. But if you want to just skip to the Passport JWT implementation, then you can just skip over all of the next videos and go down to the first video in that series. If you choose to do that, I will mention that a lot of the elementary explanations regarding the Passport.js framework is done in this the Passport local strategy, all of those videos. So it would be advantageous even if you're trying to just do the Passport JWT strategy, to watch the Passport local strategy explainer, because it's just going to give you a much greater understanding of what you're doing. So it's up to you. Go to whatever video is appropriate for your needs. Be sure to give a like and a comment, and maybe even subscribe to the channel if you enjoy the series.
Do you want to start building AI applications but don't know where to begin? Join the Langflow AI competition and learn by doing. With $40,000 in
This video is part of the Passport.js user authentication series, and there is a link in the description below to that playlist, but it can also just be used as a standalone explainer video for you that you're trying to understand HTTP headers and cookies a little bit better. So let's get started. What is an HTTP header? I think it's something that we know in the back of our heads kind of what it is, especially if we program a lot of web apps, but it's also something that we don't spend a lot of time trying to learn, and we frankly don't need to learn a whole lot about them. That said, we do need to specifically learn about an HTTP header called the set cookie and the cookie header in order to understand how server-side sessions work and kind of interact with the browser. So if we come to google.com right here, I always use this as an example just because it's a pretty arbitrary spot. If you open up your developer console here in Google Chrome, and go to the network tab, you'll see that it is pretty much empty right now. But if we click refresh on the Google search, and we're basically doing a GET request to google.com, and you'll see a bunch of stuff loading. A lot of these are the resources that run the page or scripts. But at the top, you see this www.google.com. If we click on this, you'll see that there are some headers here. And you'll see that the headers come in three basic categories. First, you have the general headers, then you have the response headers, and finally the request headers. What we're specifically interested in this case, to understand what a cookie is and how it works, is the request and the response headers. But we can also kind of explore the rest. You can go on to MDN is a great place to look, and you can see there's a link to all sorts of different headers. So we can go down here into security, and these are all the different security headers that you could set in either the general, response, or request headers. Now let's take a step back and really think about what just happened when we pressed the refresh button in our browser to load google.com. If you think about it, a HTTP client could be anything from an IoT device, someone like me sitting at my desk or at a coffee shop. You could think of it as just a laptop or a phone. Pretty much anything that connects to the internet is considered an HTTP client. Now, on the other side of things is all of the HTTP servers. And those servers, Google in this case, is going to house the information that the clients want to access or update or do other operations on. So in our case, what we did was do a GET request to google.com. In other words, we want the resources at that web page. So if you look at the headers here in the Chrome tools, you'll see, as we talked about, we have these three categories. So let's just go ahead and walk through each of them and see what was relevant to our request. So in the first one, the general headers, these can be either request or response related. They're just kind of general metadata about the request, such as what is the URL that we're requesting, what type of method are we using. So this is a GET request. Those are in the request side of things. Now if we go to the response side of things, you'll see that we got a status code of 200, which means that we requested data from Google and it sent back the data successfully. So you can see that we have several things that kind of mix between the request and response. Now in our particular situation, when we searched Google, we formed, or we didn't form, but the browser that we were using created a request header, which is basically instructions for the server in what data the request wants. So I'm the client here sitting at my computer. So the browser on my behalf is going to say, hey, whoever I'm trying to get these resources from, I'm going to put in the request headers what kind of data I accept. So you can see that we have things like the accept encoding, accept language, and then just the accept HTTP header. And we're basically saying that we accept HTML, we accept XML, and a couple other different options. But you can just think of this request header as the instructions for the server that you're requesting resources from or trying to modify. What type of data that the client, myself, will accept in the browser is not the only thing that you can put in this request header. You can put all sorts of other things. You see there's a cookie in here. We'll talk about that in a few minutes. But you also have things like the user agent tells us what browser is requesting this data. And then if, again, you can go to the MDN site and look at a broad variety of different things that you could put in the request header. So you can click on the request context and you can kind of see some of the things that you can put in that. So we know that HTTP headers are basically metadata about our HTTP request. So we can also do that on the response, which would be set by the server, which in this case is Google. So one of Google's servers, whichever gave us the content that we're viewing on the web right now, is going to set these response headers. And these response headers are going to give additional instructions to the client that requested the data in the first place. So you can go through a couple of these and see, you can see the content type. So if you remember in the request header, the client, which is the browser I'm sitting in and using right now, said I only accept a certain type of data. And then the response is going to say, okay, you only accept that type of data. Here's the data, and here is what type it is. So this is useful if we're trying to figure out how to display that data in the browser. Of course, there are other things that you'll see here, but I want to direct your attention to something very relevant to what we're talking about right now, which is the set cookie header. Now you can see that the set cookie header is basically giving key value pairs, and you can see right here it says expires equals Friday the 31st of January 2020 at this specific time. So you might be asking, well, there's a cookie header in the request object and there was a cookie header in the response object. How can that be? What is the difference between the two and how do they work? Over the next few minutes, I'm going to walk you through the set cookie header. Now you can see that the set cookie header is basically giving key value pairs, and you can see right here it says expires equals Friday the 31st of January 2020 at this specific time. So you might be asking, well, there's a cookie header in the request object and there was a cookie header in the response object. How can that be? What is the difference between the two and how do they work? Over the next few minutes, I'm going to walk you through exactly how the set cookie and the cookie headers kind of work together. And then in another video, we'll actually talk about how this all plays into what we call a server-side session. The easiest way to understand what a cookie is and how it works is to remember that HTTP protocol is a stateless protocol. In other words, it's going to constantly forget what the user has done on the site unless we have a way to remember that. So in other words, if we go to Google, let's just imagine this scenario. We go to Google and we sign in to Google. And we'll just assume they actually probably don't use this method, but we'll just assume that they're using cookies and server-side sessions to authenticate us. So what happens is Google, the server, is going to say, okay, the client that just signed in gave us valid credentials. And so what we want to do is, send something back that allows the browser to remember that this user has logged in. If we don't have anything like cookies or local storage, probably a more modern way to do it, if we don't have these types of persistent storage, then every time we refresh the page, the state that we had previously where Google said, okay, we logged you in, is going to have to be redone. So every time you refresh the page, you're going to have to enter your login credentials, which of course is a terrible user experience, and any site that does that is going to lose their users immediately because they're going to get completely tired of typing in their login credentials. So this is where the set cookie and cookie headers come in. So let's do a little experiment here, and I know this is not a perfect example, but I think it will do for what we're trying to accomplish here. So let's click on the application and open up cookies for Google. You'll see that there's all sorts of cookies. Google knows everything about everyone, so we can just go ahead and delete these. It doesn't hurt anything to delete all of these cookies. So at the moment, our browser has no cookies set whatsoever. So we can come back to the network tab and let's go ahead and refresh the page once more.
Rocks. I'm writing a paper on them. This is a lasting sign between me and Brick.
you'll see that we had this google.com here, and we can open up the response and request headers. And you'll see that in the request headers, it's pretty much the same as what we had looked at before. And then in the response headers, we once again have these set cookie headers. And what these are doing is basically saying, okay, or the Google server is saying, okay, client, I want to set this information about you. So we'll just assume maybe we just logged in, and Google wants to tell the browser that I, the client, is logged in, and we don't need to re-authenticate every single time that we refresh the page. So what happens here is we have these set cookie headers, and let's just pick a very specific key value pair here just to see what's actually happening. So let's get a pretty easy one. We'll just say the 1P jar. It gives us a date of 2020-11-21. I'm not exactly sure what that means, but keep this in mind. This is what we're going to be looking for. So if you go to the application, you'll see that now these are set in the cookies field. So we have the 1P jar and then the value that was set in this response header. So now what our browser will do is it says, okay, now we have a cookie set. So every request that we make within this domain, so google.com, I want to attach those cookies that were set based on this set cookie HTTP header in the response header. So what's going to happen is when we press refresh again, it's going to actually put these cookies in the request headers. So right here in this cookie request header, we should see something like these set cookies that Google, the server, had put into our browser. So let's click refresh once more, go to the google.com, and look at the request headers, and you can see that now this cookie header right here has that 1P underscore jar cookie key value pair. So just to recap what just happened, we had a client, me, refreshing or doing a GET request against google.com, and whatever Google server that gave me that data said, I want to set a cookie in this client's browser. So it uses the response header to do that. It assigns these values in the set cookie header, and then when we reload the page, our Google Chrome browser, or any browser for that matter, is going to say, okay, my default behavior is to look up what cookies are currently set in my browser, and I'm going to attach those cookies to every single request for the domain context that it is applicable to, which is google.com in this matter. If you really think about it, this method of setting and then the browser just attaching the cookie to each request is a really powerful thing when it comes to user authentication. You could say, hey, maybe my server can do some sort of logic and say, okay, is that user valid, invalid, did they give me the right password? If they authenticated correctly, then I do the set cookie header in the response object, and then now the user or the client that is using my web application now has that cookie that says, yes, this user has already been authenticated, and then the browser, every time it reloads, will attach that cookie, and you don't have to re-log in that user. Now the real question is, how long do we keep that user logged in? And that's a totally arbitrary question, but we can do that with the expires piece of this set cookie HTTP header. If we come over to the network tab and look at the response headers from Google, you'll see that there's the cookie that's being set, so 1P jar. It looks like this is actually set on every GET request to Google. But you'll notice that it has an expires piece to it. So this is what tells the browser how long to store that cookie key value pair within the client. So we can actually go through this exercise on our own using some simple JavaScript to see exactly how it's working. So let's go to the console and type in a few quick commands. So first, we're going to create a new date, which is going to represent the date and time right when I click enter. So we'll say enter, and then we're going to say we want to set the time 20 seconds later. So let's do that. And then finally, let's set a cookie to the browser with an expires header at that time. So we really only have a few seconds, but you can see that we have a custom cookie that's going to be there for about 20 seconds. So if we reload right now, it shows that it's gone. So let's go ahead and do that one more time, a little bit quicker this time. So here's our cookie. Go over to application. You'll see that we have the custom cookie, and every time we refresh the browser, you're going to see that cookie is going to stay there. But then in about 20 seconds, which is coming up here in a few seconds, I think, you'll see that that cookie actually will drop off and it will no longer be attached to the HTTP request. So if we refresh, you'll see it's gone, and that user will say that that was a cookie that gave a user or the client's authentication status. That's gone. The user has to re-log in. Now obviously you're not going to set a cookie to last for 20 seconds. You might more realistically say that you want the cookie to last for 2 weeks. And that is a really powerful way to keep some sort of persistent state within the browser and not require users to log in every time they refresh the page. Hopefully that made sense. You understand HTTP headers and cookies a little bit better. If you are continuing on with the Passport.js series, we'll be talking next about Express sessions and how they work with these cookies. If you're not continuing on, thanks for watching. Be sure to like and subscribe.
My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need to get done in a list view.
This video is part of the Passport.js user authentication series, and it is kind of a follow-up discussion to my video on HTTP headers and cookies. So I'll leave a link to the series playlist below and that other video, which should be just before this. It can also be used as a standalone lesson if you just want to know a little bit more about how Express sessions or sessions in general work. So in this case, we're going to be looking at a very simple Express app, and I'm going to take you through how the session is working, how the cookies kind of work with the session, and some of the configuration that you have to do to set up the Express session middleware. What I've got open right now is the repository that goes along with this Passport.js tutorial series, and we just have a folder for little one-off tutorials like this one. I've already created an application, which is an Express application, and I'm just going to quickly walk you through what I've done, and then we'll go through what's actually happening, what are some of these configuration options. So the first thing that I've done, I've already installed my dependencies. We've got Express, Mongoose for the database, and then Express Session, which is an NPM module. We then have something called Connect Mongo, which we'll get to in a few minutes. It's what we're going to actually use for the session store. Then, of course, we set up our Express app, pretty familiar to most people. We connect to our database right here. So I'm just using a completely unauthenticated localhost database. I've got that running in the background already. So if you're trying to follow along, be sure that you get the MongoDB server or that process running before you try to run this app. So we're just going to use the tutorial database, and then these options here are just set because when you run the application, Mongo is going to complain about it if you don't put these. So that is all we've got, and we create the connection right here. So the connection represents our database connection. And then down here we have some pretty familiar JSON and URL encoded middleware, which is going to allow the Express server to parse the different request types. So that just pertains to the type of responses that we're getting on the server. And then finally, we have things related to the session itself, which we're going to dive in a little bit deeper. And at the bottom, we've just got, we're listening on localhost 3000, and we have one simple route for the home page, just says hello world sessions. So that is our app. This is the only file we're working with, and so it should be pretty straightforward. Like I said, this tutorial is not an Express tutorial, and I assume that you already have a decent understanding of how the Express framework works. I'm trying to stick primarily to how the Express session middleware works. So if you don't understand how Express works or how middleware works, be sure to check out some of my other videos or just read some of the documentation online. Before we get into any of the configuration and understanding how the Express session works, we need to answer the question, what is the difference between a session and a cookie? You'll see that in the configuration I've got a cookie set, and in a previous video that I did, again, link is in the description, we talked about what a cookie was. So basically a session and a cookie are different in the places that their data is stored. So a cookie has its data stored in the browser, and that browser is going to attach that cookie key value pair to every HTTP request that it does. A session, on the other hand, is going to be stored on the server side. So when I say server side, just the Express.js application. And so this Express session is going to store a little bit bigger types of data. So in a cookie, you can't put a whole lot of data, and it gets very tedious if we're constantly adding more and more data to the cookie that we're attaching to each request. So it would make sense to put that in a server-side session where we can store much larger amounts of data. In addition, a server-side session is advantageous because with a cookie, we cannot store any sort of user credentials or secret information. If we did that, then a hacker could easily get a hold of that information and steal personal data. So the benefit of a session is basically the fact that we have it on our server side and we're actually authenticating into the session with a secret key. So with that said, that is the main difference between a cookie and a session, and I want you to keep that in mind as we're talking about the two in this video. Now that that's covered, we have some time to get into the actual code and configuration of an Express session, and then I'm going to show you kind of how it works in real time. So what we've got on the screen right now is the Express session documentation. It's just an NPM module, a pretty popular one at that. And you can see on npmjs.com, there's all the documentation that you would need to learn how to use this. But I'll just point you towards a few of the common things that you'll see. First off, of course, we require in the Express session, and then these options right here are what are going to be included in that options object. So if you look at the code here, you'll see that for our session, we're saying app.use, so that's just we want to use the session middleware, and then we've passed into the session middleware an object right here which represents our options. So if we go back to the documentation really quickly, you'll see that all of these options are documented right here under the options section. Now the one thing that I wanted to point out, you get through the options, that's great, fine. But then you get to the bottom, somewhere down here, and it talks about a session store implementation. So if you're unfamiliar with what that is, it's basically deciding what persistent memory are we going to store our sessions in. If you remember from a few minutes ago, I said that a session is used to store information about a particular user moving throughout the browser or a client. And so we can potentially get up to a decent amount of information, and therefore in a production environment, it would be useful to have an actual database storing that information. Now, by default, the Express Session middleware just comes with its own implementation of a session store, but it's not using a database. It's just using in-memory or memory that's local to your application, and it's not going to be a scalable solution. So what we need to do is set up an actual session store, which is a fancy way of saying we need to connect our database to the Express Session middleware. So there's going to be a lot of options for what session stores we can use, and they're documented here at the bottom. The one that we're using particularly is the Connect Mongo session store, which is probably one of the most popular ones, and it allows us right here to connect to the MongoDB database that we have running in our Express app. So let's go back to our app real quick and see what I mean. So to do this session store, to connect it up, we first have to have our database connection. So we talked about this a few minutes ago. Here's our connection. We're just using a tutorial database on localhost. Nothing, you'd obviously want to change this if you were in production, but we've got this running on my computer, and I can actually come down to the terminal here and run the Mongo shell, and you'll see that we can show DBs, and you'll see that we have a tutorial DB set up when we connected to this database. Now what we want to do is we want to tell the Express Session middleware that we want to use that MongoDB database for its session store. So you'll see that that happens right here in the store option of the session middleware. And so what we've done is we've passed in the session store object into this store option. And the session store object is set up right here, and it is basically just using that Connect Mongo right here, the Connect Mongo package, and we're configuring a few options. We're saying that the connection equals the connection that we just set up, and the collection that we'll be putting our sessions in is going to be called sessions. Pretty standard option that we have here. You can obviously customize it a little bit, and if you went to the documentation of Connect Mongo, there's a few other options that you can set. But what I want to show you is what is happening when we connect everything up. So in my first terminal, I will run this application. So let me go to the path here, and we're going to run the application. So we are listening on localhost 3000, and if we come into the browser here, I've got this queued up so that we currently have localhost 3000 ready to go, but I have not clicked refresh yet. The reason being is because I want to show you exactly what this middleware, the session middleware, is doing. So let's first come back to our code, and what we want to do is go to the Mongo shell, and we want to use the tutorial database. So now we've switched to the tutorial database. Let me clear the screen, and we're going to show the collections that exist in that database. When I ran the app, it initialized this sessions collection in my database. But if I say db.sessions.find, there's going to only be a couple objects in here. Let me just go ahead and drop this really quick because I think I had some stuff from previously. So let's just say db.sessions.drop. So we dropped the database. If we show the collections now, there's nothing. But if we were to come here and refresh the app, so we're using NodeMon, so if we click save, it's going to refresh the app. We're going to go into Mongo, show collections, and you see again that the sessions have been established. And if we say db.sessions.find, we shouldn't find any documents whatsoever in this collection. So we have a completely clean slate. And in order to establish a new session, all we have to do is make some sort of HTTP request to our application. So if I came to the browser and I clicked refresh here, what's going to happen is that session middleware is going to kind of fire, it's going to create a session, and then what it's going to do is create a session ID, which is going to be stored in a cookie in this browser. So just like we don't have any sessions in the database yet, we also don't have any cookies in the browser yet. So let's go back to our code, and what I'm going to do is just walk you through a few of the options, and then we'll finally see exactly how it's working. So when we set up our session middleware, we have a secret. Pretty self-explanatory, but this secret is going to, well, usually it's going to be stored in an environment variable, and you don't want to expose this to the public, because it basically says if the secret is invalid, then the session is invalid too. But in this case, I just put some secret just so that we can have it all in front of us. Then we have a couple options here, resave and save uninitialized. And these are just options relating to what does the session do if nothing is changed? What does the session do, if something is changed? And basically tells the middleware how to react to different events in the browser. You can read up on the documentation a little bit more on these options. But the thing that we're interested in, we already talked about the session store, but what we're doing is we're setting a cookie max age. So in other words, like we talked about in a previous video, a cookie can have an expires header, or not a header, but an expires property, which says after a certain amount of time, the browser is going to delete the cookie and it's not going to attach to any of the requests in the future. So in this case, we're setting our cookie equal to 1 day. And you can see the math that we're doing here in the comment. We're basically just saying 1 day, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute, and 1,000 milliseconds in a second. And so that's the math that we're doing right here to get to a full day for that expires property. So basically what's going to happen when I send an HTTP GET request to our sole route right here is the session middleware is going to initialize a session, and then it's going to take that session ID and set it equal to this, or set the cookie equal to that session ID. The cookie is then going to be put in the set cookie header, HTTP header, and then that is going to be in the response header. It's going to go in the browser. The browser is going to receive it and say, oh, you want me to set this cookie? I'll set the cookie, and now every time we refresh, that cookie will be a part of that request. So let's go ahead and do this. We're going to visit our only route in the application, and to do that, we need to go to Google Chrome, and we're going to click refresh. So when we clicked, well, now it did not load, so let me go ahead and do that one more time. We refreshed it, we get our response. It says hello world sessions, and what you'll notice is now we have this cookie, which is by default called connect.sid in the Express session middleware, and we have some sort of value here which somehow corresponds to our session ID. So basically what's happening is the Express session middleware is going to get this cookie on every request. It's going to take the value of that cookie. It's going to say, okay, look up this session ID in the session store, which is the database, and then it's going to say, is the session valid? If so, let's use the information from the session to either authenticate our user, find out some data about our user, maybe like how many times that user has visited our site. Anything of that sort is what's going to happen when the user loads a different route. You'll also see that we have an expires property right here that says tomorrow this cookie is going to delete from the browser. But for now, since it's still valid, it's going to attach to every single request. So if we go to the network and look at that last request, we'll see that in the response header, this came from our Express server using the Express session middleware, we have the set cookie header. And we set the connect.sid header and we gave it an expires. Now in the request headers, since we only did this once, you won't see any cookie. But if I click refresh one more time and we look at the request headers and response headers, you'll see that in the request headers we have the cookie that was set previously. So in other words, the browser is saying, okay, I have a cookie that is still valid. Let me attach it to every request within this localhost domain. Alright, so we have this cookie on every request now. Let's see what's happening on the back end. So let's go back to our code. And we're in the Mongo shell, so we're looking at our database right now. And we're going to type in db, well, let me clear this real quick, db.sessions.find, and that's going to look in the sessions collection for any documents in that collection. And you'll see that we have one and only one document, which represents the session that we just established in the browser. So you'll see that the ID is right here, which you can also see in that cookie that we have in the browser. So let's see, the first couple letters were capital AYYJ. So let's go back to the browser, and you'll see that the cookie right here has got that ID set in it. So that's how we kind of connect the back end to the front end. And then let's once again come back to our code. So we also have the expires header within here, so we can also validate it on the back end. And basically what this is going to do is every time the server gets that specific cookie with that session ID attached to it, it's going to come to this sessions collection in the database. It's going to grab that document out of the database or the session store, and it's going to get information that we have set onto that session and use it to do whatever we want to do with our application. Now this is great and all, but what do we actually use this Express session middleware for? Well, in another video in this Passport.js series, you'll see how Passport.js actually connects in to the Express session middleware and uses the session to actually authenticate the user. But since this is kind of a standalone video, I'm not going to get into that. All I'm going to show you before we kind of conclude is where this session is being set. Now, we know that the cookie in the browser has the session ID, and we use that session ID to look up the session in the database or the session store. Now, we can also come to our routes and get information about the session. So if we said console.log request.session, you'll get to see exactly what that session looks like, and we can actually set properties to that session. So again, I'm connected using NodeMon, so we'll automatically refresh when we save this app. So let me click Control S to save. You'll see that something happens here, so we reset, and now if we visit this route again in the browser, in the console we should see the session object. So let's quickly switch over to the browser. We'll refresh this page, and then we'll come back to our code window, and you'll see that our session object has been printed to the console. Right now all we have is a expires header and a couple other metadata properties, but what we could also, and this is set to the cookie object, but we could also set other information. So we could set something like how many visits a user has made to our page. So let's go ahead and do something really simple like that. In our only route that we have for this application, let's just say if request.session.view count, we want to say request.session.view count equals request.session.viewCount plus 1. Or you could just do the plus syntax at the end. You could just do something like that and be done with it. But we'll be really explicit here and we'll set a value. Okay, so if we have that property on the session, we're going to increment it by 1. And then what we're going to do is we're going to say in the response, instead of hello world, we're going to say you have visited this page X amount of times. So we'll use a little JavaScript syntax, and we need to change these to backticks to get this to work. And let's see, we can just put in request.session.viewCount, and now it should tell us how many times we've visited this page when we visit that page. Now we also have to say else, because in this first occurrence we're not going to have this property set. So if that does not exist, then we're going to say request.session.viewCount equals 1. Alright, so we have set a property to the session object, and let's go ahead and save this application and go to the browser and visit it. So we're in the browser now, and we will reload, and it says you have visited this page 1 times, or it should be time. But now every time we refresh, we're going to get that number to increment because of the logic that we've put into our route. So you can see how this session object could be very useful for tracking information about a specific user or client. One last thing I want to show you, if we go back to the code, you can look it up in the database again. So let's go back to Mongo and let's find that session once more. You'll see we still have just one object, one document in the database, but now we have this little property down here. So when we set the viewCount property on the request.session object, that actually persisted in the session store or our MongoDB database under the viewCount property. So again, you can see how powerful this is, and you could also kind of extrapolate out and start to foreshadow how something like a Passport.js middleware could kind of connect into this Express session middleware to keep its own sort of data. That's it for this video. Be sure to like and subscribe. If you are continuing on with the Passport.js authentication series, I think this may be one of the last kind of filler videos before we get into the actual Configuration of the Passport middleware. So be sure to check out, if you don't know where that is, the playlist is listed in the description. Otherwise, hope you learned something from this and have a good one.
Juggling multiple client sites? Supercharge your productivity with...
This video is part of the Passport.js user authentication series, which in the description to this video, I've linked the playlist to that video series, but it can also be used on its own. We're basically just going to be talking about what is Express middleware and how does it work on its most basic level. The reason for this video is I think that when you start out using Express.js as a framework, it's an entirely middleware-based framework, but generally when you first learn it, you're just copying in, the different pieces, and you know that there's kind of something working behind the scenes, but you don't know exactly how it's working. So in this video, we're going to talk about how exactly does this middleware work, and how does the request, response, and next or callback object, as well as even the error object, work in an Express application. In order to do this, we need to spin up a really quick basic application. What I'm working in here, again, this is part of the Passport.js series, so I'm in the repository that we're using for that. But don't worry, this is just a basic Express app. So we first need to require in Express. I've already installed this with npm, so I don't need to do that. And then we say app equals Express, and then we just say app.listen on port 3000. So right there is the most basic form of an Express server that you can spin up. And if we were to visit localhost 3000, we're not going to get anything. But if we just throw in one simple route, app.get, and then we pass in the request, response, and next objects, and then we send some sort of data, we can now run this in the browser. So let's use nodemon, which is going to automatically update on every time I save, and we'll run app.js. So we're running app.js, it's listening on port 3000, and it'll be listening on localhost. So if we go to the browser and visit localhost 3000, port 3000, you should see the hello world. So we have a basic server running, and that's all we need to do to start understanding how middleware works in Express. So we come back to the code here, and the first thing that you need to understand is this right here. So with our app.get, this is just a route that we've established in our Express application. We are passing in a route string and a callback function. Usually you'll see it in this syntax, but to better understand it, we can just basically write a function where we say request, response, and next. Now, to make this even more transparent, what I'm going to do is name these custom properties. So normally you're going to just see it REQ, RES for request and response, and then next. But you don't need to call them that. It's just always going to be passed in. You can call them whatever you want. So we can say request object, response object, and callback function. So, well, actually, we probably shouldn't call it the callback function. We should say maybe next middleware or something like that, because the purpose of this last parameter is if we call it as a function, it will pass it to the next middleware in the chain. So we'll understand that a little bit better in a second, but first let's go ahead and write our function. So we need to give it a function name, so we'll just say standard express callback, and we pass in these three parameters, and then we can say res.send and hello world. So basically we've got the same exact thing that we had below in the app.get route. To implement this, let's just delete what we wrote here, And let's just pass in our standard express callback. So we've defined it up here. We know that express as a framework is going to pass in these three parameters, and so there we can just throw it into our route and click save. And then if we come to the browser again, if we refresh the page, it's going to say res is not defined, and the reason being is because I was dumb and forgot to update that. So now that we're passing in request and response object, we obviously need to also use that in the body of the function. So that was just a silly mistake, but now if we come to the browser and do it again, we should get hello world as we expected. So that's the most basic way that an express route works, and we're using this function that we had defined. So just like we could define this function, we can also define other functions which we call middleware. So the way that we do that is pretty simple. We'll just say middleware 1. And what we need to do is pass in those same three objects that we were using before, so the request object, response object, and next middleware, or whatever you want to call them. In this case, I'll just say REQ, RES, and next, like you would normally see it. And then we can do whatever we want in this middleware. So maybe we'll just say console.log I am a middleware. And then in this one, this is the standard express callback. This is where we return some data. We can say console.log I am the standard express function. So if we just define that function up here and we don't do anything with it, it's not going to do anything, obviously. But we can pass that into our route to make it work for us. So let's pass in the middleware 1 and a comma. So you can see that Express as a framework allows you to pass in pretty much as many parameters to the different route functions as you want. Let's go ahead and save this real quick. Let me open up the terminal a little bit more so that we can see what's going on. And let's go to the browser and visit that same route. We'll go ahead and click refresh here, and you're going to see that this is going to just keep loading. It's not going to ever return us data. And if we were to, copy this into a new tab and click enter, it's not going to actually return us anything. And that brings up a very good point with Express middleware. If we come back to our code that we wrote, you'll notice that in this middleware that we passed into our route that we were visiting, we haven't actually called this next parameter. So in the Express framework, the next parameter is going to be actually a function, and all we have to do is call it at the bottom of our middleware. And what that's going to do is it's going to say, for this route right here, we first run middleware number 1, or middleware 1, and in middleware 1 we call the next function that was passed in as a parameter by default by Express. And when we call that, it's going to basically say, okay, now we get to go to the next middleware, or in this case it's the last one, it's the standard Express callback. So if we don't put that next function and call it, it's never going to get to this last function, and we're not going to ever return any data. So now that we've called this next function, we should be able to go back to the browser and see a response. So if we refresh, we'll see that it should return hello world, and you see that it did return it. And if we come back to our code again, you'll see in the console that we printed, I actually ran this route twice, so we printed I am a middleware and then I am the standard Express function. And the order of this is very important because first in the route we run this middleware and then we run the standard Express callback. So first we're going to console log I am a middleware, second we're going to console log I am an Express function. So that is the basics of how this middleware works, but we also have a few other things to understand. So what we've been using so far by passing the middleware into the route itself is a route-specific middleware. Now, this is kind of, I just think of it this way. I don't know if it's the exact term that you would use, but I call this a route-specific middleware, but you also can have global middleware. So if I took this out of the route and I came up to the top right under the definition for the app and I say app.use, what this function built into Express expects is a function or a middleware that it can execute. So in this case, I'm going to just take middleware number 1 or middleware 1 and say app.use middleware 1. So what's going to happen is the Express app is going to initialize, and then it's going to initialize the middleware 1. So let's go ahead and see what happens in the console when we do this. So let me make sure I got this right. So we've got our middleware defined here. We call next, and we're initializing it with the app.use up here. So let's save that, and you'll see that nothing has happened in the console yet. You might expect, since we did this outside of a route, that it would just automatically print I am a middleware, and go to the next something. But that's not the case. When we say app.use, it's basically just adding a piece to that chain of functions or middlewares that we're going to be calling. So once again, we have to come back to Google Chrome and execute this get route. So let's enter, and so it loads correctly. And then if we come back to the code again, now you're going to see I am a middleware and I am the standard express function. So what just happened here? Well, first off, we defined that this is the first middleware that we want to use in all of our routes. It's not just specific to this particular route, it's going to happen in any route that we define within our application. Next, we have the standard express callback, which is in this specific route. And so it loads correctly, and then if we come back to the code again, now you're going to see I am a middleware and I am the standard express function. So what just happened here? Well, first off, we defined that this is the first middleware that we want to use in all of our routes. It's not just specific to this particular route, it's going to happen in any route that we define within our application. Next, we have the standard express callback, which is in this specific route. So first, the route's going to call middleware 1, then it's going to call whatever we had defined as the callback to that route. So the order of the middleware that we define and the scope, whether it's a global or a route-specific middleware, really matters. So let's go ahead and see what happens if we switch up the order of the middleware and maybe even add another middleware into this equation. So let's say we have another middleware called middleware 2, and again we pass in the default objects that we are provided by or provided with by the Express framework, and we'll say console.log I am middleware number 2, and maybe we should just update this one up here to number 1. So we've got middleware number 1 and middleware number 2, and what I'm going to do is say app.use middleware 2. Okay, so we are using two middlewares, and then we have the standard express callback, which at this point I'm just going to go ahead and put it in a form that we're used to seeing. So we'll just use request, res, and next. This is what you'll see in most tutorials, so I want to keep it consistent. So let's copy that in there, delete the function declaration, and then of course, since we changed the name of the parameter, we need to also change the name of the object that we're using to send the data. Alright, so let's just quickly recap what we got. We have one route in our application which has a very standard syntax. All we're doing is we're sending back an h1 tag with hello world in it. So far in this route, we haven't defined any route-specific middleware, but we have defined global middleware. So let's see what happens. Go ahead and kind of make your guess as to what's going to happen here. But if I had to guess, we're probably going to print I am middleware number 1 and then I am middleware number 2 when we call that route. And then finally, we'll console.log I am the standard express function. Alright, so we've saved it. Let's go back to the browser. Click.
Let me respawn in Rome, please. Yes!
Our city currently has a population of 9. A farmer?
Refresh. And I don't know why it hangs sometimes here. Try it again. Maybe we have some sort of error. Did a little bit of refactoring. Nope, it was doing just fine. We've got all the things that we expected. So if you could guess, what's actually happening here is, again, we forgot to call the next function in the middleware 2, so it never reached this final function. Save it once more, come to the browser once more and refresh. We should get a good response. Come back to the code and you'll see I am middleware number 1, I am middleware number 2, and I am the standard express function. Alright, so everything is as expected. And now is where the real understanding comes into play, because oftentimes when we're using an express application, we've got all sorts of middleware working together. In most Express applications, you're going to have several app.use statements. So you might say app.use cores, cross-origin resource sharing, that's a pretty common one, or app.use body parser, and then whatever the configuration for that was. So you might have up to like 10, 15, even 20 different middlewares that you are adding to your Express application. And so it's really important to understand that the order that we put these in matters. So if we were to put middleware 1 after middleware 2, all we did was change the order of those statements. If we save and then go to the browser and call that route, you're going to notice that when we come back to the code, we now have things out of order. So we have IAM middleware number 2 coming before number 1. So that's really important to understand. And then, of course, if you put one of these within the route itself, it affects the order as well. So let's add one more middleware to this equation. And let's just copy this, do the same thing. So we'll call this one number 3. Number 3 right there. And then we're going to take middleware number 3 and put it in the route itself. So let's copy it right there, give it a comma, and now what's going to happen is we should have middleware 2 called first, then middleware 1, then it goes into the route specific middleware, so then we have middleware 3, and then finally this last function, which we technically could call middleware as well. So let's see if that worked. We should have middleware 2, 1, then 3. So let's go to the browser, run the route, come back to our code, and you see that we have 2, 1, and 3, exactly how we defined it, 2, 1, and then the route specific middleware. There are 2 more things that I want to talk about when covering the topic of Express middleware. And one of those is error handling, because an error handler in Express is also just another middleware, but it's actually a special type of middleware. So in order to define an error handling middleware, what we have to do is define a function with a 4th parameter. So let's go ahead and define a function called error handler. And you'll see that in this app I've kind of simplified it a little bit, so we only have one middleware. We got rid of all the rest of this stuff. But this time we're going to pass in an error parameter, then the request, res, and next parameters. So this is how we define an error handling function, and we can, this is basically a middleware, so we can do as many error handlers as we want. So if we wanted to catch specific types of errors, so we say if error.status equals something, then we want to, handle it in this one, and then we could come down and do another error handler and say this is error handler number 2, and if error.status is number 2, number 1, you kind of get the point. We can define as many of these as we want and handle different types of errors depending on the application that we're doing. But what is going to happen here is this error parameter will be populated with an error if it exists. So what we can do is we can say something like, maybe instead of throwing the error explicitly, we'll say if there's an error, what we can do is res.send, and we can say there was an error, please try again. So something more friendly than a default error that you might get in the browser that would crash the entire application. So let's go ahead and comment this out for 1 second and see what happens if we don't have an error handler. So right now we don't have an error handler, and maybe in this middleware up here, instead of console logging I'm a middleware and continuing to the next, we can say that we have an error object, which is a new Node.js error, so I am an error. And what we can do with this is we can pass it in the next function. So normally we just call next and it goes to the next middleware. This case, we're going to actually pass the error object. So this would be common, this would be more common in a scenario where maybe our middleware was doing something complex. We were making a database call and we were just catching any errors that happened with the database, something that we cannot control. So we always want to catch these errors, and if we do catch them, we want to pass them in the next function. So when we do that, we're going to go back to the browser real quick. And if we refresh this, it's going to say I am in error. And you're going to get the entire stack trace, which you don't want because this is where the users will see what's going on, and you obviously don't want to send this type of error to a user. You want to handle it in a more graceful way, and not to mention, if we do it like this, you can see down in the console or in the terminal that we've crashed our application. So if this is running out on a server somewhere and we don't know that this has happened, our application could be down for hours without us even knowing. So it's really, really important that we use an error handler in our Express application to catch these errors and handle them gracefully without crashing the Express application. So again, error handler, just another middleware with one extra parameter. So let's uncomment this error handler function. And normally you'd set this up a little bit more complex than what I've done, but we'll just go with this for now just to demonstrate the point. So we've got the error handler, and so now we're going to say app.use error handler. Now we'll go to the browser again, we'll refresh, and now we're getting a more friendly error message. Now that we've defined this error handler, let's go ahead and put it in as a middleware. So let's just say app.use error handler and click save. Now let's come back to the browser real quick and refresh. You're going to see this dreaded error message in the browser. And you're going to ask yourself why. We defined our error handling middleware, so we should have a friendly message here. Well, what's happening is we have done this out of order. And like I said earlier in this video, the order that you put Express middleware in matters. And in this case, we need to throw our error handler at the very end of our app. So after all of our routes and all of our middleware, we need to put our error handler. And the reason being is because if there is an error in any of our middlewares or our routes, which are basically just middlewares, then the error is going to be passed directly to the final error handler. So in this case, we have the error happening up in our first middleware. So what's going to happen when we say next and then error, Express is going to pick up on this and say, oh, there's an error. Let's send it past, let's skip the route here. We don't need to go into this. We need to just go straight to the error handler and handle it appropriately. So this is kind of how Express middleware works, and you can see that this will more gracefully handle the error if we come back to the browser and refresh. Now we're getting a much more user-friendly message. In many cases, you might do something instead of actually sending data like this, we could just say res.json, and then we could say error, and then our front end application could handle this error on the front end rather than the server handling it. Alright, so we have covered how to handle errors using error handling middleware. And finally, the last thing that I think is important to cover when it comes to Express middleware is the fact that we can actually mutate or kind of append different properties and objects and functions to these parameters that we're passing through each of the middlewares. So what we could do here is let's get rid of the error in this middleware. Let's also get rid of the console.log. We just want to have a basic middleware. Let's call this number 1 again. Then let's say number 2. And let's put these in as global middlewares. So here's middleware 1 and 2. So first our route's going to call middleware 1, then 2, and then the actual callback for the route. So to demonstrate this, let's go ahead, come up to middleware 1 and say something like request.custom property equals 100. All right, so we just created a variable that is attached to the request object. Now, since Express as a framework passes this request and response object through each of the middlewares, it will actually be available to us in later middlewares. So what we can do is we can say we define it up in middleware 1, then in middleware 2 we say console.log the custom property value is, and then let's put in that custom property. So in middleware number 2, we should print the
engineer ng Bulacan, dito sa Cordillera, ang bahay niya na ito ay nanganganib ng bumagsak. Kapagkat nagawa niya ito sa kontraktor na kaya. This is the most feared man in arm wrestling, Devin Laird. He has spent decades mastering the art of strength, technique, and mind games. But can he get a beginner like me ready for my first ever arm wrestling tournament in just 24 hours? To find out, he's putting me through the exact routine that has turned him into the greatest arm wrestler of all time. Devin, hey brother, how's it going? Are you again? Good to see you too in a bit. Oh, I'm feeling that strength right away. You would say, oh my God, I heard you're currently in your strongest and heaviest you've ever been. We're 2 weeks away from Arlington. Ready to go after the number one spot North America. Yeah, you got that up to. Yeah, I'm actually also preparing for my first ever arm wrestling. Saan ka bisa po ko? Yan ang boyfriend ko. Nalarangan. Pagkami kong matutaanan.
They never had a pretty girl from Joburg.
The custom property value is 100, but then we want to reassign it. So let's say custom property equals 600, just a random number. And then finally, down in our routes, we'll say the value is, and then we'll put in request.custom property. And in this case, it's probably going to print, or not probably, it will print 600 because we have modified the property in middleware number 2. So let's save that, go to the browser, and see what we get. So we see that the value is 600, and that is because we set it in our